Hello learners, in this lecture I will discuss about structure of igneous rocks. This very interesting topic. First I will introduce the two important terms, structure and texture. There is always some sort of a confusion or some sort of a misuse of these two terms. What is structure and texture? Let us discuss clearly here. Structure is a larger feature visible on the outcrops. For example, lava flow beds and layering and vesicles. They are the larger structures. They can be seen on the outcrops. So they are categorized as structures. Structures on basalt outcrop can be seen vesicles or amygdales. Amygdales means infillings. Whereas texture is smaller structure. It cannot be seen without the aid of a microscope. So texture can be seen or studied only under the microscope, whereas structure can be seen with unaided eyes or naked eyes. Broadly speaking, the vesicular and amygdaloidal structure. These are the two important structures. As you understand, magma is a molten rock material. When it comes to the surface, it is called lava. Lava is always loaded with volatiles, gases. It is enriched with gases. Lava eruption on the Earth's surface causes volatile escape from the fluid. Naturally, when it is magma, it is the volatiles, they are under tremendous pressure, they are in the soluble state and they are under the pressure, they are dissolved in the magma. Once they come to the surface, the pressure is lessened and suddenly released. With the loss of pressure, the volatiles, they get escape out, the gases, they escape out of the magma and forms the cavities, or which we call it as vesicles. They are in the form of bubbles or vesicles. They are of varied size and shapes. They may be spherical, they may be elliptical, they may be cylindrical or irregular. Such openings are called as vesicles, and structure is called as vesicular structure. Now vesicles later on are filled up by some low temperature secondary minerals. They are in the form of solution and they get deposited into the vesicles and they crystallize in the form of a quartz crystals or calcite or zeolite or chalcedony. It is termed as amygdale. The secondary silicates or carbonates filled in the vesicles are called as amygdales. The volcanic rocks containing amygdales are said to have amygdaloidal structure. The entire structure is called as amygdaloidal structure. They are called so because their shape sometimes resemble with the almonds. Here is the picture of a vesicular and amygdaloidal structure. Here you see on the left hand side of the photograph, you have an open space vesicles here, and these vesicles are filled up by secondary silicates and carbonates. Their vesicles are filled up and they are amygdales. This is amygdale, this is vesicle, this is actually vesicle filled with amygdales. Here the entire vesicle is filled up by secondary silicates, carbonates. Now volatile fluid cavities and their texture, depending upon the degree of vesicularity, they can be divided into different types: vesicular, pumiceous, scoriaceous, and later on when these open spaces are filled up by secondary silicates, they are called amygdaloidal or buggy structures. What is the difference between scoriaceous and pumiceous structures? There are two types of structures. They can be distinguished here. On cooling, gaseous escape from volatile enriched lava produces clinkery, highly vesicular basalt called scoria, and structure is known as scoriaceous structure. On cooling, gaseous escape from volatile enriched siliceous lava produces irregular abundant vesicle, produces pumice. What is the difference between scoriaceous and pumiceous structure? The vesicle, if it is greater than 50%, both the cases the vesicle proportion is greater than 50% of the bulk, but there is a marked difference in the density. In case of scoriaceous, you have a density greater than 1, but in case of pumiceous rocks, the density is always less than 1. Less than 1 and greater than 1, that is the only difference. What are the wugs? Angular cavities formed by collection of volatile fluid between existing crystals. The structure is called as wuggy structure. Wuggy structure can be of 4 different types. Wuggy fabric, which is called angular wugs between crystals. Muriatic cavities, wugs in pheneritic rocks called muriatic cavities. Dictectic texture. Coarse-grained basaltic lava flows consist of angular wugs. Lithofissile texture called hollow bubble-like gas cavities in rhyolitic lava flows. Here is the picture which shows vesicles and amygdules. In this case, volatile fluid bubble becomes vesicular as magma solidifies. The texture is vesicular. Highly vesicular silicic glass or pumice having pumiceous texture. Scoria and scoriaceous are terms for andesite and basalt. These are the terms scoriaceous is applied for andesite and basalt. These vesicles are filled up with secondary minerals producing amygdules and amygdaloidal textures. The texture is called as amygdaloidal texture. Now we discuss another important structure called lava tunnels. Lava fluids on cooling drain out through channel ways and forms lava tunnels. You see this picture here. This line, yellow color line, shows a vertical, almost vertical tunnel-like structure. It gets hardened from the side walls. Hardened basaltic flows contain cave-like tunnels, serve as conduits. These caves, they serve as a conduit to carry out lava called lava tubes. This entire structure is called as lava tubes. What is the significance of lava tunnels? It serves as insulated pathways and facilitate lava propagation to great distances from the source. The another important structure is lava structure, which is again of 2 types, blocky lava and ropey lava. Blocky or AA type lavas, they are basically sluggish lavas, form sharp edges, varied size angular blocks with spiny rough surface outcrops. And the other one variety is called ropey lava or pahoiho lavas, also known as pahoiho lavas. They are highly mobile lavas, form smooth, glazed and wrinkled surface of ropey outcrops, which is akin to twisted ropes. You can see here this picture, you can find out these twisted ropes. Here you can see it looks like a rope-like structure and ropes are twisted together, and here you have a blocky lava. This block is there. This is called a AA type of lava and this is called a ropey or pahoiho lava. Here is again a picture of a ropey lava. You can see rope-like structure here, and then another structure which is very commonly seen in case of volcanic rocks is platy and sheet structures. Platy structures, they are different when different joint sets form platy rock mass traversed by closely spaced irregular joint planes. See this left hand side photographs. Here these joints, several joints, vertical as well as horizontal joints, they crisscross the entire mass of the rock and they are very much closely spaced and they are irregular joints. You can see irregular surface and rock mass, this is called the platy structure. Whereas sheet structure, you see this is a horizontal sheet, this is another horizontal sheet. The sheet after sheet is lying on the ground. We call it as a rock mass with the growth of one set of horizontal joints is called a sheet structure. Another important structure seen in case of volcanic rocks is the pillow lavas. They look like a pillow. They are ellipsoidal pillow-like structures. Structure occurs in basic mafic lavas formed by cooling of lava under waterlogged seawater or rain-soaked air or beneath the ice sheets, having vesicular grassy crust or chilled margin due to quenching. This diagram, if you see left hand side here, they look like a pillow-like structure. It's a pillow-like structure. Normally they are formed when sudden quenching of the lava is taken place in a water body or in the ice covered areas or the waterlogged areas. You see here, this is the outer crust which is glassy sometimes or fine grained. Here is again a second photograph is also there, in which you can see here you have a outer thin layer which is glassy or fine grained layer, and inner this material is almost a shape like a pillow. Another important structure in the volcanic terrain can be seen is a homogeneous magma. When homogeneous magma cools and contracts uniformly, parting planes form prism-like columns due to growth of nucleation contraction centers at equally spaced contraction centers. You see here they are called columnar structures, columnar joints. These are the joints, same on the surface, it looks like this surface on the, when you view from the top of the surface, it looks like you have sometimes a hexagonal joint here, and you have a contraction and expansion, nucleation, all directions of the center, nucleation center is equal. Then rift and grain structure, three sets of mutually perpendicular equally spaced joints produce cubical blocks known as mural joints can be seen here. In this diagram you see three mutually perpendicular joints can be seen here, or this structure is called as rift and grain structure. Another important structure on the volcanic rocks can be seen is the lava flow structure. The lava flows just like a sedimentary rocks. They are lying over each other and form a step-like topography. Here you see flow structures in Deccan basalts. Eruption of lava on the surface faces difficulty in movement due to viscosity, resulting in the formation of dissimilar elongated lenticular patches arranged parallel to the flow of the lava called flow structure. This is flow structure. This is the example of a rhyolite in which you can see the flow structure. Here the flow structure is on a larger scale and the thickness of the flow structure is much higher, whereas the flow structure is thinner here. Each layer is very thin here in case of rhyolitic lava flows. The another important structure which can be identified, which can be frequently seen on the earth in volcanic rocks is the perlitic structure. Perlitic structure is a fracture controlled alteration generated a jigsaw texture on a centimeter-millimeter scale. Remnant arcuate perlitic rocks or cracks enclosed around fragments of microlites composed of feldspar. So these are the cracks actually. They are present in the glassy or very fine grained rocks. Because of cooling, these cracks are there, and these cracks, along these cracks the alteration has taken place, and as a result the perlitic structure is formed. This is perlitic structure, and these are all the microlites. These microlites are lying here, and in between these microlites you have a perlitic structure. The very common structure which can be seen not in volcanic rocks but even in the plutonic rocks, the Rapa-Kivi structure. What is Rapa-Kivi structure? Is a rounded ovoid potassic feldspar crystal. This is rounded orthoclase crystal here, mantled by white plagioclase rims. These are the white plagioclase rims. Mostly this structure is found in granitic rocks. Here an example is a field photograph of a orthoclase. Here is the orthoclase in the center, which is ovoid in shape and surrounded by a plagioclase, which is grayish black in color here. Rapakvi structure, how it forms magmatic, it's a magmatic texture in which an alkali feldspar is rimmed by plagioclase. Example is Rapakvi granite. Here is the photograph which shows a Rapakvi structure on the outcrop. Polished surface of a Rapakvi granite, feldspar orthoclase without rounded orthoclase without plagioclase rims, and typical orthoclase feldspar with darker plagioclase rims. Here you have a darker plagioclase rims here, consisting of orthoclase with plagioclase rims. Finally, how it looks under the microscopes. This is a sanidine high temperature rich alkali feldspar here, black colored, surrounded by polysynthetically twinned oligoclase. This is polysynthetically twinned oligoclase, plagioclase. These feldspars were produced by mixing of a sanidine bearing rhyolite magma with basaltic andesitic magma. Another important thing is xenoliths. Xenoliths are accidental foreign rock fragment trapped inside in any other igneous rocks called xenoliths. It may be igneous, the accidental material may be derived from igneous sedimentary or metamorphic origin or a metamorphic source. Xenoliths which are genetically related to host igneous rock, they are called as cognate. Crystals accidentally incorporated but partially reabsorbed in magma and preserved called as xenocryst. Cognates are xenocrysts genetically related to enclosing rock. Here we have a xenolith here, and next is the inclusions. The xenolith is also an inclusion. Restite is a aluminous body. Normally it is derived while partial melting of the mantle and the clay material is incorporated in the magma. Sometimes cognate, I have already discussed, inclusions or otoliths, crystallized part of information lifted away from the margin, and chromospheric is the accumulation of mafic minerals or big crystals at one place. Blobs are partially or completely recrystallized mantle derived basaltic magma. Then we come to the volcanoclastic fabric, that is pyroclastic fabric. Pyroclastic fabric related to consolidation of volcanoclast into solid rock. One is welding and fusion, that is an exotic texture, rheomorphic texture, and devitrification and vapor phase crystallization, which is also felsitic and spherulitic textures. Volcanoclastic fabric related to fragmentation of the magma, that can be classified on the basis of size, ash size particles. Then we have lapillis and bombs. Lapillis are smaller size particles ranging in size from 2 to 64 millimeters, whereas blocks and bombs, they are much bigger particles ranging in size greater than 64 millimeters. Composition wise also we can classify volcanoclastics into lithic or vitroclastic. Lithic means clast polygranular mineral aggregates lapillized to block size, whereas vitroclast fragments of melt quenched to glass are of any size. Heritage, the origin wise, the cognate derived from magma consists of glass accidental clast or xenoliths derived from older rock or vents. Here is a photograph which shows a volcanic lapilli. This is a volcanic lapilli. Are spheroidal teardrop, dumbbell or button shaped droplets of molten and semi-molten lava ejected from volcanic eruption that fall onto the earth's surface while it was partially molten. They directly result from liquid rock cooling as it travels through the air. This is the photograph of a volcanic lapilli. This is a larger structure of volcanic called as volcanic bomb. This is the whole volcanic bomb, larger than 64 millimeter diameter, formed when volcano ejects various viscous fragments of lava during an eruption. Because volcanic bombs cool after they leave the volcano, they are extrusive igneous rocks. And finally, the process of fragmentation, we have pyroclastic, autoclastic, epiclastic and glass shards. Pyroclastics or tephra, pyroclastic falls, they are in the form, mostly in the form of falls and flows, pyroclastic flows, and in the form of pyroclastic surge. Surge is a dilute concentrate of solid particles into hot gases. Here is the fragmentation of a highly viscous siliceous melt that creates S-size glass particles. These are glass shards which are angular Y-shaped, tear-shaped or teardrop-shaped and arcuate slivers shown here. And finally, we summarize the entire study into we have discussed various structures found in igneous rocks such as vesicular amygdaloidal structure, pumiceous lava tunnel, blocky and ropey lavas, pillow lavas, columnar structure, platy and sheet structure, lava flow structure, Rappakivi structure, volcanic bombs, volcanic lapillis, and finally xenoliths. Thank you very much.